हेलो गाइस। आज हम लोग ना मर्ज शॉर्ट समझने वाले हैं। तो बेसिकली सॉर्टिंग क्या होता है कि सॉर्टिंग इज अरेंजमेंट ऑफ एलिमेंट्स ऑफ एन एरे और लिस्ट इन इंक्रीजिंग और डिक्रीजिंग ऑर्डर। तो मर्ज शॉर्ट जो है ये डिवाइड एंड कॉन्कर स्ट्रेटजी बेस्ड सॉर्टिंग एल्गोरिथम है, जिसके थ्रू हम लोग एक एरे को ऑप्टिमल टाइम कॉम्प्लेक्सिटी में अरेंज कर देते हैं। सो द मर्ज सॉर्ट एल्गोरिदम जो है ये बेस्ड ऑन डिवाइड एंड कॉन्कर स्ट्रेटजी पे बेस्ड है। और इसमें हम लोग क्या करते हैं कि वी डिवाइड द प्रॉब्लम इनटू सेवरल सब प्रॉब्लम्स and each of which is solved individually, and after that all of them are combined to give the final solution. तो इसको जॉन वॉन न्यूमैन ने इन्वेंट किया था 1945 में, एंड वी कैन विजुअलाइज इट एज अ रिकर्सिव एल्गोरिथम दैट कंटिन्यूअसली ब्रेक्स द एरे इनटू हाफ until the array is left with only one element, right? This is the base condition to stop recursion. And then each call returns to its parent and arranged to return the sorted array finally. And successful sorting approach to divide the problem into to divide the problem divide the problem into many subproblems and it is invented by John von Neumann. John von Neumann. In 1945. So it splits the given array. It splits the given array into two equal halves. Into two equal halves until the size of subsequent halves becomes one. Then call itself for the two halves and merges the two sorted parts to perform merging we must define the merge method. We must define the merge method. The merge function. Okay. So to combine two halves, this is the second point, this is the first point, and this is the third point. To combine two halves together, we use the merge function. Merge function. We use the merge function. The merge array, okay, lower bound, middle bound, and R, LM and R key process assumes that ARR L L to M and ARR M plus 1 to R are sorted. This is an array, so I have to use the square bracket, not the round bracket. Are sorted subarrays. Are sorted subarrays. Subarrays. And merges the two into one. And merges the two into one. 2 into 1. Okay. Fine. And the subproblems are divided into halves, until the list cannot be further divided. Until the list cannot be further divided. That is the size of the list, becomes 1. Then we combine the two element. Then we combine the two element, then we combine the two one element list to one element list, right? Because it contains only one element at the end. So to one element list, which increases the size to 2, which increases the size to 2. The size to 2. And then we combine the two elements, and then we combine we combine, and then we combine two elements, then we combine two element list to form four element list and so on until we get our whole array sorted. I hope this much is clear, right? So what is divide and conquer approach, right? So divide and conquer approach comprises of three steps. Split a huge problem into sub-problem, that is called breaking. Solve the sub-problem separately, that is called solving. And finally combine them once again to get the final assortment as per needed result, that is called combining. Okay. Fine. So let me write it down. So divide and conquer approach. So this is what we are doing over here in the merge sort, right? So divide and conquer approach and conquer approach. Conquer approach comprises three steps. So first is split the huge problem into sub-problems. Split a huge problem into sub-problems. That is by breaking. Next is solve the sub-problems separately. Solve the sub-problem separately. That is solving. And the last step is combine them once again to get the final result as per requirement. Final result as per requirement. So this is called combining. So three things are there. First is breaking, second is solving, and third is combining. Okay. So let me write down, let me take one array and then let me try to explain this process. Okay. So the array is, let's take this array, and the array element is 22, 16, 45, 30, 19, 6, 29, 55, 43, 61, 15, 70, and 9. Okay. So these are the elements which is stored in one array. Okay. So I'm writing down the indexes of the array: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So here you can see that there were 13 elements, right? So now when you divide the array into two parts, right? So first 6 elements or the first 7 elements, so 13 by 2 is 13 divided by 2 is basically 6. If you are going with the floor of 13 by 2, because if you do integer division, then it will be 6. Right? And after 6, right, the elements from the 7th position, right, the elements from the 7th position till the end position, it will go to the right part of the array. So here we have two arrays. One is this array, right, and another is this array. Okay. So here we have 22, 16, 45, 30, 19, 6, and 29. And here we have, this is one part and this is another part, right? So in the right hand side, what we have 55, 43, 61, 15, 70, and 9. Okay. So now this is the lower bound of left side and this is the higher bound of the left side, and this is the lower bound of left side and this is the higher bound of right side. Okay. So now again we do the same thing, right? So here we have higher bound is 6, so it will be 6 divided by 2, that is equal to 3. So 0, 1, 2, 3, right? So this many element in the left side, this will go left side, and from after this it will be in the right side. It will be in the right side. Okay. So now you can see here. So here we have 22, 16, 45, and 30, and here we have 19, 6, and 29. Okay. So let me try to create some spaces in between these divisions, because I need to write down the dry run of the merge sort in between these spaces. So I'm creating more spaces so that I can write down the dry run of these, right? So here also I'll create a little bit more space so that I can write down the. So here we have done the division, and this is okay. So again we divide this array into two halves. Fine. So this is 0, 1, 2, and 3. So the higher bound is 3. So 3 by 2 is 1. So here we have 22. Here we have 22 and 16. And this side we have 45 and 30. 45 and 30. Okay. So this is the division. And here we have 4, 5, and 6. So 6 plus 4 is 10, and 10 by 2 is 5. So we do the division like this: 19 and 6 one side, and 29 will be on the other side. 29 will be on the other side. Okay. So now we do the division again here. So we have here 22 We have here 22 and this side is 16. We have here 45 and the next part is 30. Here we have also two parts. One part is having 19 and in another part we have 6. Okay, we have 6 here and 29 is as it is. Similarly, 7 to 12. So 7 plus 12 is 19. 19 by 2. 19 by 2 is 9. Okay. So till 9 it will be here. Say 55, 43 and 61. Okay, 7, 8, 9. So will be this part. And the other part will be 15, 70 and 9 will be on the other side. Okay. So this again we divide into two parts, right? So 55 and 43 will be here. 55 and 43 will be in this side. 61 is alone. And for this case, we have 50 and in this case we have 15 and 70 at one side, and then 9 is on the other side. 9 is on the other side. Okay. Then we divide these two. We divide these two, we get 55. This is 29. 55. This is divided into two parts. So one part is 55, other part is 43. 61 will automatically come down. Then 15 we have. 15 we have. Then we have 70 and 9 is here only. Okay. Got it? So to better understanding, that is why I have drawn all the elements. Okay. So now what will happen? Now what we do, we start merging it down, these elements. Okay. So first we merge these two elements. First we merge these two elements. Then we merge these two elements. Then we merge these two elements. Then we merge this element, these two elements and this element, and then we can continue like this. Okay. So then we merge this two element, then we merge this two element, then we merge these two elements, then we merge these two, and then what we do, we merge this and this. Okay. In this way we will merge, right? That merge sort algorithm will go on and then it will solve the problem. Okay. So let's see how it is going on. So let me write it down here. Let me write it down, the merging process. So you can see the merging process here. Say 22 and 16. So I'm changing the color here. So I'm writing it in purple. So 22 and 16 will be merged and will having a new array which contains 16 and 22. Then we merge 45 and 30. So we have a new array called 45 and 30 and 45. These two will be merged in this way, 30 and 45. Then we merge these two array. So we have 6 and 19. Okay. Then we merge, then 29 will remain alone. This is 29. Okay. Now what we do, we merge these two array, this array and this array. Okay. So when you merge these two array, you will get 16, 22, 30 and 45. Okay. Fine. And when you merge this array and this array, you will get 6, 19 and 29. Now what we will do, we'll merge this array and this array. So when you merge this array and this array, you will get 6, 16, 19, 22, 29, 30 and 45. So now you can see that the array, this part of the array is in sorted order. Okay. Now what we do, we start, then after completion of this, we start merging this and this. So we'll get 43 and 55. Okay. Fine. Then we merge this and this array. On the other side, we'll get here 61 will come down here, 61. Then we merge this and this array, so that will be 15 and 70. This two array, and 9 will as it is. So now what we do, we merge these two array. Okay, so here we get 43, 55 and 61. Then we merge these two array, this and this. Then we'll get 9, 15 and 70. Okay, then after this we merge this array and this array. We get here 9, 9, 15, 43, 55, 61 and 70. So we have got the right side array. Then what we do, we merge these two arrays, this array and this array. So we get the final array here. So final array will be first is 6, then 9, then 15 will be compared with 16. So 15 we have, then 43 will be compared with 16. So we have 16. Then we have 19, then we have 22, then 29, then 30, then 43, then we have 45, then we have 55, then we have 55, then 61, then 70. So now you can see that that array is in sorted order. Okay, this is how merge sort sorts the array. Okay, I hope you people have understood it. Fine. So what I'm doing, I'm writing down the code and then I will explain you with some dry run. Okay. So let's go to the computer and write down the code. Yeah. So we write here hash include IO string then we write here using namespace std, and after that what I'm going to do, I'm going to write down a function to print the array first. Function to print the array. Function to print the array. Function to print the array. So I'll write here void display, and I will pass the array, and I will pass the size. I can use something called size underscore t, and then size size. Okay, so this is the prototype of the method, and after that I will write down void merge function, merge, merge function. In the merge function I will pass the array, and I will pass the low, I will pass the low as integer, and comma I will pass high. High is required, and I will pass one middle also. So integer of mid. Okay, so mid will also help us. So this is the merge function. Then I'll create another function called merge short. Let's create a function called merge short. Okay, so void merge sort. So I'm writing it in merge sort, and in the merge sort I will provide integer of array, and then I will provide integer low, comma integer of height. Similarly. So this is the merge function, merge sort function, and then what I will do, I will write down the main function. Okay, so I'll write here main function, and inside the main function, what I will do, let me create this same array which I have created in my example, right? So let me write it down, integer a, or you can feed the array according to your need also. Say you can declare a variable called size here, and here you declare a variable called size underscore t size, and you can take the input from the user also. You don't have to initialize it, you can write it down, cout, enter number of elements in the array. You can feed that semicolon, and then you write it down cin size, then the size is there, and we can use the size. Okay, so this is our array variable, and now what we do, we need to perform input in this size. Okay, so what we can do here, we can declare a variable integer of i, because we need to feed the data, so we need to create a loop here, right? Feeding data to the array. So what we can do here, we can, instead of creating this kind of an array, what we can do, we can create a pointer variable here, integer star a, and we can write here equal to new int size. Okay, so we can do this. So this will create a dynamic array, and which is very much useful. Okay, and after that we can use it. Okay, so feeding data in array by generating or best option is that this is a class which I'm recording. So best option, I was thinking that we can create the array directly. We can create the array. So what I'm going to do here, I'm going to create the array. So I'm going to write the integer a is the array equal to. Best option is that I can create the array so that I can show you the demo properly. Fine, without doing any more experiment and confusing you how to generate the random numbers and all. So let me write down my values. My values are 22, 16, 45, 30. 22, 16, 45, 30. So I'll write here 22, 16, 35, 55, 40. Okay. So 22, 16, 45, 30. 22, 16, 45. This will be 45 and this will be 30. This is 30, right? And after that, we have 19, 6, 29, 55. 19, 6, 29 and then 55. Yeah. Okay. So I'm not going to leave spaces. So I'll put this 55, comma, and then 43, 61, 15. 43, 43, 43, 16. 43, 16, no, 43, 61, 15. 43, 61, 50. 61, 15. 43, 61, 15. Then 70 and 9. 70 and 9. 70, comma 9. So this is my array, and this array I'm going to use for the demo purpose, right? So I'm not feeding the array. So I've directly used the array, and what I can do, I can print the array before sorting. Okay. So in the display function, what I'll do, I can pass a string here. So string string, which I can use, and I name them as message. So whatever message I will pass over here, I will do that. Okay. So here I'll declare the class hash include, and I will write here string. So I'm going to use the string class, right? So here const is not required, so I'm not going to use const. So now what I can do, I can print this array, right? Printing the array before sorting, before sorting, before sorting. Okay. So I'll call the display function right, display method, and in the display method I'll pass the array, and I'll pass the lower bound, right? I'll pass the, no, I have to pass the size. So the size of the array is, it contains how many elements? So 2, 4, 6, 8, 10, and 3, 13 elements. So let me write it down, 13 here. And here I can pass a message, array before sorting, array before sorting. Okay. So I passed this message, and then let me write this, and then we'll write here print array after sorting. Okay. So what we do here, we call the sorting function, right? Say to sort, call the sort function, calling the merge sort function. So what we do here, we write merge sort, we pass a, the lower bound is 0, and the upper bound is merge sort is lower and higher. So upper bound is so a dot length minus 1. So length is 13. So 13 minus 1 is 12, right? So here in the comment I'm writing length of the array is 13. So the requirement is length minus 1. Length minus 1. So I passed 12, right? 12. How I got 12? 13 minus 1. 13 minus 1. Right? This is the requirement. So 13 minus 1, which is equal to 12. That is equal to 12. So that is why I passed 12. Fine. So now, so this is I called the merge sort, and now I'm going to print the array after sorting. So I'll call the display function. So I'll call the display function with this, and I will write down the message array after sorting. Okay. So now what I will do, now I will write down the functions one by one. Okay, fine. So I'll write down the functions one by one. Let me write down the functions one by one. So first, I'm going to write down the print array function or display function. So I'll write here void display, and in the display, I need to pass the array. Array. I need to pass the array, and I need a size underscore t, the length, and I will write down the message string message msg. So what I will do, I will print the message first, cout. First I will change the line, and then I will print the message, and then I will write it down endl. After that, what I can do, after the endl, I will print, I will write here a square bracket open, and yeah, so I'm going to print the array in this format. So I'll declare one variable called I, and I will write it down here for I is equal to 0, and after that I will write it down I is less than length and I plus plus, and then I will write it down here cout a of I, and then I want to give a comma and then a space. Okay, and I will not write down endl. Here I'll put a semicolon, and what I will do here, I will write it down length -1. I will print the last element outside the loop, right, to give the output as an elements of array. So I will write here cout the array element, the a of I, and then what I will do, I will write down the closing bracket, and then I will write it down endl. Okay, so this is the display function. And after writing down the display function, let me try to write down the merge function first. Okay, so we'll write down the merge function. So merge function is what merge function is doing. It's merging the two parts, right? So low to mid and mid plus 1 to high. Okay, low to mid and mid plus 1 to high. Okay, so we create void merge, merge, and we write here integer of a. Here we write it down integer of low, comma integer of mid, comma integer of high. Okay, integer of high. Now what we do, we declare a few variables here, like integer of I, comma j, comma k. Okay, and now we declare two variable, right? We need the left array, right? We need the left array, left high, or the left, right? We need to point to the left, right? So left is equal to, we write here left high, left, or yeah, we can say left high. We can say left high is equal to, right? So what we can do here, we can write it down. Left high will be left high will be mid minus low plus 1. Mid minus low plus 1. So this is the left high, and we need to the length of the right. There's a length, actually, length of the left array. So length of left length. So let's name it as length left. LENGTH, length left. This is a left array length, and then we write it down. Right RIGST. We can write it in this way. We can write it in like this: left array length. Left array length. So let it be a meaningful name, and this will be a right RIGST, right array length. So right array length is equal to high minus mid. High minus mid, right? So this will be the right array length. Okay. So now what we do? High minus mid. So now we declare two arrays. Okay, integer. Okay, left array, LEFT, left array, and here we use left array length, comma, we declare right array length. Okay, so we have declared two arrays, and left array and right array. Then what do we do here? So what we have to do here, we have created two arrays here, left array and the right array. Fine. And what we do here? We write here. What we do here? We write here. We copy the data from actual array to the left and the right. Okay. So for doing that, what we do? We write for I is equal to this, and then so this must be a constant. So let me write it down here, const. And this will be also constant. So let me write it down, const. Okay. And then what is the problem over here? It's marking with this constant left array length, constant right. Must have a constant value in C++, but it is a constant value, so I won't have any issues with this one. We'll fix it later on. What do we do here? We write it down left array. We'll write it down here, left array. Left array ARR of I is equal to ARR of low plus A is equal to A of low plus I. Okay. So in this way, we have started copying the data into these two arrays. So we write here for I is equal to 0, I plus plus, and then again what we do here, we write here a right array of A, and here we can write it down mid plus 1, mid plus 1 plus I, mid plus 1 plus I. Okay, so we have done this much, and then what we do, then what we do, we merge the temporary array, right? So merge the temp array, the temp arrays, temporary arrays back into the original arrays, back into the original arrays. This is what we have to do. Okay. So now what we can do here, we can write it down here. We can write it down here. So we write here I is equal to 0. We can create a for loop here. For I equal to 0, j is equal to 0, j is equal to 0, and k is equal to, k will be starting from low, right? K will be starting from low, and after that what you will do, you will write it down. You will write it down, I is less than, I is less than, I is less than length. We have left array length and we have right array length. Okay, so we write it here, I is less than left array length, and we write, sorry, and j is also less than right array length. Okay, and then we write down j plus plus also. Okay, so we don't write here I plus plus and j plus plus. Let it be, let's do it depending upon a condition. We increment the value of I and j, right? Because what we are doing, we are going to merge the array. Okay, so here we write down if left array of I is less than equal to a right array of is less than equal to a right array of j, then what we do, we write here a of k, we write here a of k is less than equal to, sorry, a of k equal to left array of I. Okay, and then we can increment the value of I here. So we can use the postfix operation. Fine, so the value of I is updated. Okay, after that what we can do, we in the else part, if this condition is false, okay, if this condition is false, what we do here, we update the value of a of k, and here we write down right array of j plus plus, right? So j is updated in this fashion, and we have to update the value of k always. So here we can write it down k plus plus. Okay, so because k needs to be updated even if the condition is true or false, we need to update the value of k. Okay, so after successful execution of this loop, what we can do here, we need to copy the remaining elements of the left sub array if it is there, and if it is not there, then what we do, we will not execute this loop, and we try to write down the right sub array, elements of the right sub array that can be used. Okay, that can be used. So what for doing that, what we will do, we'll create a loop here. So we write here, what I can do here, I will write a loop here. We can use while loop, or we can use for loop also, but we can use while loop, no problem. So let me write down that part here. So after completion of the above loop, after completion of above loop, right, we need to copy the left array, the left sub array. Okay, this is what I'm going to do in this while loop. So I'll write here while I is less than left sub array length. Okay, and here what we can do here, we can write it down, capital A of I plus plus equal to, right, left array of I. No, what we do now, we write here I plus plus. After adding the element, we need to update the value of I. Okay, and similarly we have to copy the right sub array also. Okay, similarly if a right sub array, sub array having some element copy to the original array. Okay, so same thing which we are going to do. So while and what we are going to do here, we write j. Okay, j and equal to right array of j plus plus. So here instead of I, what we have to do, we have to use j, because j is pointing to the right sub array. Okay, so we have done this, and after that, what we do, the merge function has done its merging. So what do we do here? We write down. So we have written the merge function, we have written the print function, and now we need to write down the merge sort function. Okay, so we are going to write down this function. So we are going to write down the merge sort function. So merge sort function is very easy. So I have to declare a variable called mid here, and mid, and what I do, I will write down a condition here. If the value of low is less than high, if low is less than high, then what I will do, then I will calculate the mid. So mid is equal to low plus high divided by 2. Low plus high divided by, right? And after that, what I will do, I will call the merge function. Okay, so merge sort, and in the merge sort we pass the array, comma, and here I will pass low, comma, mid, right? I'll go till mid. Okay, and when this function does solve the problem, then I will call the merge function again to merge the right part. Merge sort and here I will write a comma, okay, mid plus 1, a comma mid plus 1 comma high, okay, mid plus 1 comma high, okay. So let me put the semicolon here, and after doing these two merge process, what I have to do, I have to merge the array. So I will pass merge. In the merge, I will pass the array, I will pass low, I will pass mid, I will pass high. I will pass mid and I will pass high, ch high. Okay. So this is the code for the merge sort. Okay. So let me save this first, and let me explain you this process, how this process is going on first, and then I will execute it. Okay. So this is the merge sort, and I want to do the dry run of the merge sort. Okay, let's start the dry run of merge sort. So here the value of low is, the value of low is 0. The value of high is 12. And the value of low is less than high. So mid is equal to low plus high by 2. That is 12 by 2 is 6. So mid is 6. Now, there is one recursive call is there, a, low and mid. So the value of low in the next call, the value of low will be 0. Low will be 0. The high is going to be mid. The value of high is 6. The value of high is 6, right? But there, before calling this function, there are two lines which are due to execute, this line and this line, right? So let me feed out these two lines, right? These two are the due statement, and these two due statements are feeded over here. So due is merge sort, due is merge sort. The value a is the array, and mid plus 1. So mid plus 1 is 7, and high, the value of high is 12. And after that, it is calling the merge function. So merge is array, low is 0, mid is 6, and high is 12. Okay. So this is how merge function is being called, but it is due, it is not called, right? So in the second call of merge sort, we have low is equal to 0, high is 6. So 0 is less than 6. So this condition is true. So it will execute mid. So mid is equal to 3. The value of mid is 3. The value of mid is 3. Okay. The value of mid is 3. So now merge sort. So there is another function called merge sort, and here we are passing a, low. The value of low is 0 again, and the value of high, the value of mid is 3. But before going to this call, we have two due statement, right? So the due statement is the due statement is merge sort a. The value of mid is 3, so 3 plus 1 is 4, and the value of high is 6. Okay. And after that, there is another do statement that is called merge. So merge array, the value of low is 0, the value of mid is 3, and the value of high is 6. Okay. So now there is another call. So let's focus on this call. So we have low as 0, mid equal to 3, fine, and sorry, not mid equal to 3, high is equal to 3, right? Not mid equal to 3, high equal to 3. It will be high variable. So we'll write here high equal to 3. So 0 is less than 3, condition is true, so the value of mid will be 1. The value of mid is 1, fine. And again, this function will be called merge sort. This function will be called merge sort. The value of array will be A, low will be 0, low is 0, high is actually mid, so the value of mid is 1, so high will become 1 in that case because it will be copied to high. And now again we will write down the do statements here. So do is merge sort the array A, right? Then mid plus 1, the value of mid is 1, so 1 plus 1 is 2, and high, the value of high is 3. Okay, then merge A comma low, mid comma high, then it will call the merge method. So the value, so array is A, low is 0, mid is 2, and high is 3. So this will be get called. Okay, so now let's focus on this call, low equal to 0 and high equal to 1. So 0 is less than 1, condition is true. So now the value of mid will be 0. The value of mid is 0. So now merge sort, there is another method to call. There's a method call out here. So the value of low is 0, high is equal to, high is also 0 because mid is 0, because the value of mid is 0, so high is 0 in the next call. And we have the do statement, right? So the do statement is merge sort the array and the mid plus 1, right? So the value of mid is 0, so it will be 1, and high, the value of high is also 1. Okay, then we'll call the merge function merge. So we merge the value of array A, the value of low, the value of mid, and the value of high. Okay, so we are going to merge these. So 0, 0, mid is also 0, and then 1. Okay, so now this function is called again, the value of low is 0 and the value of high is 0. So this condition is false, right? So this condition is false. Then what will happen? You can see here how the array is being divided, right? So your array is being divided here like this. Your array is divided. If you see the last call here, the last call, low is 0, high is 1, and mid is 0, right? You see this call, right? So low is 0. So low is 0 and high is 1. Low is 0 and high is 1. So low is 0, high is 1. Okay. and after that the call is low is 0 and high is 0, right? That means low and high both is this same. This is 0 0. Low is also 0 and high is also 0, right? That means our element is divided into single cell. Our element is divided into single cell. Fine. Now what will happen? Now this condition is false. So it is inside the stack, right? So what will happen? It will execute this merge sort, right? It will execute this merge sort, right? So this call is over now. Now it will execute this call, right? The call is merge short a1 comma 1, right? So the value will be after this call, the value of low is going to be 1. The value of low is going to be 1, and the value of high is also 1. Okay, the value of low is also 1 and the value of high is also 1. Okay, so now this is the call. Okay, this is the call, and after doing this call, right, after doing this call, what is the case? So after doing this call, we have the value of low is less than high. The value of low is less than high. So the value of low is 1 and the value of high is also 1. Okay, so this condition is false again. This condition is false again because the value of low is 1 and the value of high is 1. And here we have one due statement. Here we have one due statement. Here we have one due statement called merge. Merge, M-E-R-G-E, merge a comma, the value of low is 1, the value of so the thing is this key, this condition is actually false after this call. This condition is actually, after this call, the condition is actually false. This condition is actually false. Okay, so after this call the condition is false. So it will, what it will try to do, it will try to merge these two values. It will try to execute the merge, right? It will try to execute this merge because this condition is false after this call. Okay, so you can see that the value of mid is 0, the value of low is 0, and the value of high is 1. Okay, so after this call we are going to merge these two elements, right? These two elements will be merged. These two elements will be merged. These two elements will be merged. These two elements are going to merge after this call. Okay, these two elements are going to be merged after this call. And in the merge function, you have seen that okay, this will be copied to the left array, this will be copied to the right array, and after copying these two elements, we try to put one condition, and then according to the condition, we merge the two elements of the both the elements, means all the elements of the left array and all the elements of the right array into the original array, right? So these two will be merged, right? So this call, you can think that okay, this call is over now. This call is going to be over now. This call is going to be over now. Now we have this call, merge short a 2, 3, right? This statement will execute. Okay, because these two statements are due. So first this statement is there, so this will execute. So what this statement will generate, right? So when you call this statement, it will call the function again, right? So the value of low is, the value of low is, the value of low is going to be 2. The value of high is 3. The value of high is 3. Okay, the value of low is 2 and the value of high is 3. Fine. So now what it will do? So 2 is less than 3. Condition is true. So now we have mid value. Now we have a mid value which is equal to, this mid value is equal to, so low plus high by 2. So 3 plus 2, 5. 5 by 2 is 2. So mid value is 2. Now we have the merge function call again. So we have a merge function, right? Which is this call, right? Which is this call. So we had a call here. Now we had a call here. This call is over now. So we had a call here, right? So the value of low is 2, the value of high is 3, and the value of mid is 2. So we have a call here. So the call is making the value of low is 2, the value of low is 2, the value of low is equal to 2, the value of mid is 2, the value of mid is 2, which is equal to high is equal to 2, and we have a due statement, and we have two due statement here. One is merge sort, this is due, merge sort in the bracket A. So mid plus 1 is 3 and the value of high is also 3, and we have merge also, and we have merge, which is array. The value of low is 2, the value of mid is 2, and the value of high is 3. Okay, so we had a call, right? So low is equal to 2 and high is equal to 2, right? After this call, okay? So the value of low is less than high, right? So this condition is false. If this condition is false, then it will execute this merge, right? Which has the value A, which has the value, then again this method will call, right? Because this condition is false, so this call will get over. Okay, now this condition, now this will execute this call, merge A 3, 3. So now again we have low is equal to 3, low is equal to 3, and high is equal to 3, right? Low is equal to 3 and high equal to 3. So again this condition is false, right? So when this condition is false, that means that this call is also got over. Now this statement will execute merge A 2, 2 and 3. Fine. So lower bound is 2, middle is 2, and high is 3. So it will execute 2 and 3, right? So you can see that this is 2 and this is 3, and merge function is executing on these two, right? So we will receive this array after this call. Okay, we will receive this array. In earlier call we have received this array, and now in this call we have received this array. Okay, because the value of lower bound is 2, middle is 2, and the high is 3. So basically it will merge these two arrays, right? 2 and 3 separately. This 2 and 3 are separate. This 2 and 3 are separate because 2 is middle and 3. So now it will merge these two arrays. So we'll get here 30 and 45. I hope it is clear. If it will not be clear, then comment me. I will try to make you understand in the comment. Okay. Fine. So this is how it is going on. Okay, so now this whole call got over. Now this whole call got over, and now I'll write it down. Better option now. I'll write it down. This part, merge a22 comma 3 has created this. This call is created with the help of merge a 2, 2 and 3. Let me write it down in this way. Merge a 2 comma 2 comma 3 has created this array, right? This call is being created with the help, this array is being created with the help of merge a 0 comma 0 comma 1, right? This call has created, right? This call has created the second one, right? So now you can see that this call has over now. Fine. Now this call is over. Okay. So now we have this merge a 0 comma 2 comma 3. This is left, right? Now this will execute. Okay. So merge a 0 comma 2 comma 3. So now you can see 0, 2 and 3, right? This is in the middle. Fine. So what we are going to do, we are going to merge these two arrays, right? So if you divide 3 by 2, you will get 1 here. So what will happen? Here these two arrays will be merged. These two arrays will be merged by this call, merge 0 comma 2 comma 3, 0 comma 2 comma 3. By this call, we are merging this, and this is the resultant array. This is the resultant array, right? So we have completed this, right? So we have completed this call. Okay. So now let's focus on this call. Let's focus on this call, right? So we are going to execute this call, merge sort a comma 4 comma 6. Now this call has happened. Okay. So now see the value of low and high. The value of low is 4. The value of low is 4. The value of high is 6. The value of high is 6. So the call is there. So low is 4 and high is 6. So condition is true. So you are here. So mid is equal to low plus high by 2. So the value of mid is 5. The value of mid is 5. Okay. Now merge sort a. So the value of mid is 5. Okay. So now you are here, merge sort a. So there is a method call here. There is a method call. Okay. So method call, in the method call, what we have? We have array a. We have low, which is 4, which is equal to 4, and we have high. We have high, which is equal to 5, right? And we can see the do statements here. There were 2 do statements. So first do statement is merge sort. The first do statement is merge sort array mid plus 1, that is 6, and high, which is also 6. Okay. Then merge. Okay. Then we have merge over here. Merge a. The value of low is 4. The value of mid is 5. And the value of high is 6. Right. So now we have this call, low equal to 4 and high equal to 5. Okay. So now we have this call. So now let's focus on this. So we had this call, and low is less than high, which is true. So now we have mid here. So the value of mid will be 9. 4 plus 5 is 9. 9 by 2 is 4. So the value of mid is 4 here. And we had a method call here. We had also a method call. See it closely. The value of low is 4. The value of high is also 4, right? Okay, and we had two do statement. We had two do statement here. Okay, we had two do statement over here. Merge sort a comma then mid plus 1, which is 5, and we had high is also 5, and we had merge also, merge, which is a, the value of low is 4, the value of mid is 4, and the value of high is 5. Okay, so now this call went away, this call went away, and the value of low is 4 and the value of high is 4, right? So now this call is over. So this call is over. Now we have merged A445. So let's go back to our diagram. So now you can see this is 4, this is 5. Let me draw it here. This is 4 and this is 5. So now what we are going to do, we are going to merge this array 4, 4, 5, right? So this is the call, merge. I'm writing here, merge a 4, 4, 5, right? Then we have these two elements. Okay, fine. Then we have these two elements. So now this call is over. Okay, so now we are back to this call, merge sort 6, 6, right? So the value of low, so from here I'm writing the value of low is 6, the value of high is 6, right? So this condition is again false. So if this condition is again false, then this call is over. Now it will execute this merge a 4, 5 and 6, right? So 4, 5 and 6, you can see it here. So this is 4, 5 and 6. So 4 is the lower bound, right? 5 is the middle and 6 is this, right? This is the sixth element. So this call is merge array 4, 5 and 6. It will merge and it will create this array. I hope it is clear this much. Now if you are not clear, then comment me again, I will answer you. Okay, now again let's go back here. So this call is over, right? This is over, right? So we have executed this merge. So this is over, right? Now we call this merge a 0 to 3 and 6, right? So now you can see this merge, right? A 0 to 3 and 6. So see one thing, this is 0, this is 1, this is 1, this is 2, this is 3, okay? And this is 4, this is 5 and this is 6. So what call we are doing? We are calling merge a 0, 3 and 6, right? So now we are going to merge these two array and we'll get this resultant array after this call. Okay, after this call you are going to get that array. Okay, so this call is over now. Okay, so now we are in this call. Okay, now we are in this call. Okay, so we have to execute this do statement, right? What this do statement is stating that. Okay, so I'm going a little bit down, or I can draw it over here. Okay, so I'm drawing it over here. I'm trying to draw it over here. Fine. So let me draw this. So let me draw this. So the value of low is 7. The value of low is 7. The value of high is 12. And then this method call is there. This method call is happening out here. Okay. So this method call is here. So the value of low is 7, the value of high is 12. The value of low is 7, high is 12. The condition is true. So we'll get the mid value. So the mid value is 9. Okay. So we have got the middle value, which is 9. Fine. Now we have the merge sort. Okay. So merge sort A, low and mid. So there is another method called merge sort here. We'll write the do statement, and we had a call, right? We had this call. So the value of low is 7. The value of high is 9. The value of high is 9. Okay. And we had some do statement. So we write down the do statement, which is merge sort, right? And here what we are doing, we are writing down the array, the value of mid plus 1, which is 10, the value of high is 12, and we had another statement here. So I'm writing it in one line as we have a lack of space. So what I'm going to do, by putting the semicolon, I'm writing down the next statement here. So merge A, comma, the value of low is 7, the value of mid is 9, and the value of high is 12, right? So I have written the two statement at one go in one line, right? So that I can save a little bit of space, right? For doing future calculation, or the best option is that I can shift this. What I can do, I can copy this and I can copy this in the later half. Okay. So I'm copying this. So I copied it. This is the first call, right? I have copied it, and I'm copying it here only. Sorry, what I have had copied. Let me copy this again. Okay, so let me copy this here, and after this we had this call. So what I do, I copy this, I'll cut this, and I'll paste it here. I'll paste it here. So this is the call after this call. This is the call after this call. This is the call after this call. Okay. So what we can do here, we will here mark it like this. Okay, this call. So that it will be understandable when you read the notes. Okay. So the value of low is 7. The value of high is 9. So let's copy this code also once. And we'll put the code here. I hope I can solve it in this much. Let's put the code over here. Yeah. Same. Yeah, now it is fine, I hope. We'll change this line. This code, the explanation is this. Okay. So now let's see this. Okay. So the value of, I hope this much is clear, and I'm moving ahead. So the value of low is 7, the value of high is 9, right? And then we had the value of low is 7, the value of high is 9, and we had a method call, right? The whole thing isn't copied, so let me copy this line also separately. Otherwise, it will be difficult to explain moving up and moving up there. Okay, so let's use this. Okay, so now the value of low is 7, the value of low is 7, and the value of high is 9. Okay, so now what we are going to do, the value of low is 7 and the value of high is 9. So there is a method called, so low is less than high, condition is true, so we have mid here. So value of mid will be, the value of mid will be, so 9 plus 7 is 16, 16 by 2 is 8. Okay, so this condition is true, so we have got the value of mid. So now we have this call again, now we had a call again, now we had a call again, now again we had a call, and in this call we have the value of low will be, let me draw it properly to save some space so that I can explain you in one screen. Okay, so the value of merge sort is going to be, the do statements are going to be merge sort A, the value of mid plus 1 is there, so value of mid plus 1 is 9, the value of high is going to be 9, and then we have merge method. So I'm writing down the next merge, which is also due merge. So merge will contain the array A, the lower bound which is 7, the middle bound which is mid is 8, and the high is 9. Okay, so this call will be made. And now we had a call we had a call merge, which is low. Low is, the value of low is 7, the value of low is 7, the value of high is 8, right? So low is 7, high is 8. Now again we had a call, right? We had a middle, we had a mid, because this condition is true. Condition is true because the value of low is 7, high is 8. So mid is equal to low plus high by 2. So low is 7, high is 8. 7 plus 8 is 15 by 2 is 7. The value of mid is 7. Now we had a call low is equal to 7 and the value of high is also 7. Okay, the value of high is also 7. Now let me write down the do statement here. So do statement is merge sort the array, right? The value of mid plus 1, which is 9, and the value of high. Value of high is also mid plus 1 is not 9, it is 8, and the value of high is also 8. Okay, the value of high is also 8, and the merge function, we write down the merge function here. The merge function is A, the lower bound, right, the middle and the high. Okay, so now this is a function call, and now this condition is false, right? So when this condition is false, it will execute the first due statement, right? It will execute the first due statement, which is this merge sort a 8 comma 8, right? So when this statement is executed, the value of low is 8 and the value of high is also 8. The value of high is also 8, right? So when this call is executed, now the condition is low is less than high, so this condition is also false, fine. So when this condition is false, it will execute the merge method. Okay, so what we need to do, we need to merge A778. So let's see in the diagram, A778, A778. So this is 7, this is 8. And now what we need to do, we need to merge these two. We need to merge these two. So what we have to do, we have to write here merge A 7 comma 7 comma 8, and we get this value and we get this array after merging. Fine. So this merge is over. Now you can see that this merge is over. This merge is over. Right. Now we go to this merge sort call. So this merge sort is saying A99, right? So the value of low, sorry, the color hasn't changed. The value of low is 9. The value of low is 9 and the value of high is also 9. The value of high is also 9. So when the value of low is 9 and the value of high is 9, then this condition is false, right? So when this condition is false, it will execute this merge method, right? Merge A789. So let's see what is A789, right? So merge A789. So now you can see here, this is merge, this call is merge. Let me change the color here. So this call is merge. This is 7, this is 8, and this is 9. So merge A, 7, 8, and 9. So now it is merged and this array is generated. Okay. So now this call is over. This merge is over. Fine. This is also over. So now what we do, we execute this merge statement. This merge statement will be executed. Merge A 10, 12, right? So now there is a call here. So now you can write it down. The value of low is 10. The value of high is 12. Okay. So this is a method call. So low is less than high. Condition is true. Then we have mid also. So mid is equal to low plus high by 2. So low plus high by 2 is how much? 22 by 2 is 11. So the value of mid is 11. Okay. So now after this, we have got the mid. Now we have a call merge sort A low comma mid. So we had a call here. So we had a call. I want to do it in one line. So we write here low is equal to 10 and high is equal to 11, right? And we had a due statement. So we'll write down the due statement here. So due statement is merge sort array middle plus 1, which is 12. Then we have high, which is also 12, and merge array, and we had the low. The value of low is 10, the value of mid is 11, and the value of high is 12. Okay. Now what we do, we had another call. So value of low is less than high, condition is true. So now we had a mid element. So low plus high by 2. So 21 by 2 is 10. Sorry, 21 by 2 is 10. because we are doing integer calculation. So mid is 10, right? So now mid is 10. So now we had merge A low comma mid. So again we had a call. We had low as 10. The high is also 10. And we had due statement. Okay, so in due we have merge sort. We had merge sort A, then mid plus 1. So mid is 10, so it will be 11. And the high is also 11. And we had a merge method. Merge A, comma, the value of low is 10. The value of mid is also 10. And the value of high is 11. Okay, so now we had a call low 10, high 10. So low 10, high 10 condition is false. So it will execute the due statement. So this is the first due statement. This will be executed, right? So the value of A 11, 11, right? So when this call has happened, the value of low and the value of high. The value of low is 11 and the value of high is also 11. Okay, so again the condition is false, right? So it will execute this merge statement. This is over, then it will execute this merge statement A 10, 10, 11. So let's see this. What is 10, 10, 11? Okay, so let's see the array here. So now you can see this is 10, right? This is 11. So 10, 10, 11 will be merged, right? So this call is merge A, 10, 10, 11, right? Then it will generate this array. Okay, I hope it is very much easy, right? So now this call is over. Right? Now the due statement is this one, merge short A 12, 12. So now the value of low is 12 and the value of high is also 12, right? So 12, 12 means condition is false. Now you can see the condition here, low is less than high. So this condition is also false. Right? So now this statement is over. It will execute the next due statement, which is A 10, 11, 12. So merge A 10, 11, 12 will execute, right? So this is 10th element, this is 11th element, and this is 12th element. So now we had a call merge A 10, 10, 10, 11 and 12, right? So these values are going to be merged and will get this array. Okay, so we have got this 2 array, fine. Now this call is over. Fine, so this call is over. Now it will call the merge A 7, 9, 12. It will call A 7, 9, 12, right? So let's see 7, 9, 12, right? So this is 7, this is 8, this is 9, this is 10, this is 11, and this is 12, right? So merge A 7, 9, and 12, right? Will create this array. We'll merge these 2 arrays and it will create this array. Fine. So this call is also over. You can see that this call is also over. Fine. Okay. So now this call is over. Now we go back to go back here, right? Now we had this due statement, merge short A 7, 12. Okay. So you can see that A 7, 12 is over now. What is over now? A 7, 12 is over now, right? So this call is over now. Okay, and we are left with this call. We are left with this call, merge A0612. So we'll put here merge, we'll write here merge A 0, 6 and 12, right? So you can see here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Right? Now we are merging these two array and we have got the sorted array. Now our array is in the sorted order. Okay, so this is what code I have written, right? In the code also I have written this. Okay, I've tried to write this, I have written this, and let me execute this code to show you the what I have done. Okay, so let me save it and we'll start this. Okay, so let's execute this. It is not showing the right kind of answer because of some reason. So let me show you how this code is executing. All right. Let me execute this code, and now you can see the output. That is array before sorting and array after sorting, right? So before sorting, the array is not in sorted order, and after sorting, the array is in sorted order. Fine. So this is how merge sort works, and I've tried to explain the dry run and as well as the merge sort logic. Fine. So this is the code which I'm attaching with the notes also. Okay, fine. And let's try to work out the. Let's try to work out basically what is the analysis. Basically, we think about what is the performance of the merge sort. Okay. So what we can do here, okay, merge sort. Merge sort actually uses the recursive routines. So what we can do here, we can say analysis. We'll write it down here first. Analysis of merge sort. Analysis of merge sort. Merge sort. Analysis of merge sort. We can assume here the value, the number of elements in merge sort, we assume number of elements elements, that is n is a power of 2. N is a power of 2. So that we always split into even halves. We always split into even halves. Okay. For n equal to 1, the time to make merge sort is constant. The time to merge sort is constant. Okay. Which we will denote by 1. Which we will denote by 1. Which we will denote by 1. Okay. For n numbers, for n numbers, for n numbers, right, is equal to the time to do 2 recursive merge sorts. 2 recursive merge sort. Okay. Of size n by 2 plus the time to merge okay, which is linear. Okay. So the following equation, so let's create an equation. So the equation, right, the equation is like this. So time for one element is 1, but time for n element is 2 into time for n by 2 plus n. Okay. So this is a standard recurrence relation, right, which can be solved several ways. Okay. So we show 2 methods to solve it. The first idea is to divide the recurrence relation through by n, and the reason for doing this will become apparent soon, right? This yield sorting, right? If you divide by n, so what you will get? You get Tn by n 2t n by 2 divided by n by 2 and plus 1. Here you will get plus 1, right? And if it is if it is t n by 2, if it is t n by 2 divided by n by 2, n by 2 is equal to 2. So n by 2 by 2. So it will become 4, right? So it will become t n by 4 divided by n by 4 plus 1, right? And t n by 4 divided by n by 4 is equal to t n by 8 divided by n by 8 plus 1. Okay. So this is going on and on and on, right? So similarly, we have t2 divided by 2 is equal to t1 divided by 1 plus 1, right? So now add up all the equations. Okay, now add. So this is equation number 1, this is 2, this is 2, this is equation number 2, this is equation number 3, this is equation number 4, right? And this is equation number n, right? If you add all of the equation, right? Add all the equation, add all the equation, right? So this means that we add all of the terms on the left hand side and set the result equal to the sum of all the terms on the right side. Okay, observe the term t n by 2 divided by n by 2, okay, appears on both the side, right, and thus cancels. Okay, fine. So this n by 2 will appear here also. You can see it is appearing over here also, right? So we can cancel this out. Very simple, we can cancel this out. Okay, we can cancel this out. Fine. So you can see it is appearing with, that is why we can cancel it out. Fine. So what we will get? So we will get here, after adding all the equation, we'll get here t n by n equal to t1 by 1 plus log of n we will get, because all the other term cancels and there are log n equations, right? Because this is why we are getting this, because all of the other terms cancel, and there are log n equations. There are log n equations, right? So all the ones at the end of these equation add up to log n, right? And so all the ones at the end of these equations, at the end of these equations, add up to log n, add up to log of n. Okay, so multiply through n gives the final answer, right? So you multiply n both sides, right? multiply n both side will give you the final answer. Multiply n with both sides, that's both sides, right? We get t of n equal to n log n, right? N log n plus n, n log n plus n. Okay, so this implies to order of n log n. Okay, this implies to n log n, right? So notice that if we did not divide through by n at the start of the solution, right, the sum would not telescope, right? So that is why it was necessary to divide by n and alternate divide by n's, right? An alternative method is to substitute the recurrence relation continually on the right hand side. Okay, so alternative way is also there to prove this. Alternative way. Alternative way is what? So we have Tn is equal to 2t n by 2 plus n. Okay. So since we can substitute n by 2 to the main equation, right? So if you substitute n by 2, so here you get 2t n by 2. Okay. So here you get 2t, or we can write it like this, 2t n by 4, n by 4 plus n by 2 plus n by 2 plus n by 2. Fine. And what we can do here, we can take 2 common here. 2 here and this. Okay. This. So this is equal to 4t n by 4, 4t n by 4 plus n. So if we take 2 inside, we'll get this, right? Again by substituting, n by n 4 into the main equation, right? So what we will get? We'll get here 4t n by 4, right? Which is equal to 2t n by 8 plus n by 4, fine? So this is equal to 8t n by 8 plus n, right? This is what we are getting. Okay. So we have En is equal to 8t n by 8 plus 3n. Okay, plus 3n, right? So continuing in this manner, we obtain Tn is equal to 2 to the power of k, T n by 2 to the power of k, plus k into n, okay. And if you use, or you can write using you can write here using k is equal to log of n, right? We obtain, right, Tn is equal to n T1, right, plus n log n, which is equal to n log n plus n, okay, which is equal to n log n plus n, right? And this is the you can say worst case scenario, worst case complexity, average case complexity, and best case complexity of merge sort is order of n log n, okay, order of n log n, and the base of log is 2, okay, base of the log is, so this is what the analysis of merge sort is, and I have done the coding and I have shown you the dry run. So I hope you people will understand what is merge sort, and you people also understand how divide and conquer technique works. Okay, thank you.